Chad Collett is our third and final speaker. So Chad has an unusual background in that he comes from an interesting part of the world on the east coast of Canada, and is the son of a fisherman in Newfoundland. But he also is a diver and has completed an electronics engineering technology degree at college. He founded his own company in his basement, so like a proper startup story, and has grown that company now to 25 people, and they serve 140 organizations in 30 countries, so a true growth story. And he, as we were just talking before, is a really interesting niche in that he's helping all of the people who are collecting data, categorize it and use it, or get it prepared for automation, which means that the companies who want to do machine learning, machine vision, can be more successful. So Chad, over to you.
Thanks, Al. That was really kind.
You're welcome.
I couldn't say it that way myself, but that was great. All right, so hi everyone. So I'm going to be talking about scripting in the subsea. So using scripting to reduce autonomous system complexity and cost. So it's quite relevant for this time slot, which is why we're all here. So first, we're going to go over a company overview, a little bit about Subsea. Then we're going to talk about what is scripting and why would you script, with a live product demonstration, and then what are the benefits with some real world examples and videos, and a little sneak peek into a new real-time streaming service we're working on. Subsea Imaging develops advanced camera and video solutions, and thanks to our focus on reliability, modular design, and dedicated after-sales service, when a customer decides to use a Subsea camera, they can be confident that we are committed to your success. With years of experience in our field, we're able to easily navigate meticulous evaluation process that businesses and researchers must adhere to when picking who to work with. Our customers do not choose their partners lightly because of the long-term equipment investment. Here's a global snapshot of some of our customers. We have over 160 clients who operate in every ocean on the planet. So enough about that, onto what we actually are for. What is scripting? Scripting is a simple software language that, in this case, allows the solution to run autonomously. Scripting uses the Subsea open source API, our scripting, which runs inside the camera, and the camera is an embedded system. The user writes scripts referencing the Subsea API to complete their desired functionality. Subsea has created examples of scripts which can help with advanced applications. The API has conditional statements that allow users to execute commands based on the state of other input variables such as time or external sensors. There are also two time sources available, the built-in real-time clock and external network time protocol. So this is a script line here, which uses system time. And when the system time modulus 5 equals 0, it takes a picture. So what this means is every 5 minutes, there's a photo. It's a time lapse, simple time lapse script line. What we're showing in this graphic is the idea of sensor fusion. So all of your data comes together to create an accurate picture of the environment. Subsea cameras are data loggers, and that data can be used for scripting in real time with conditional statements. So most NMEA format sensors can also be logged, including depth, altimeter, and CTD. So in this little script line, you can see when the depth is greater than 5, it can start logging. It's another simple script line that can help with automation. The API allows the user to control external sensors directly. The aux ports of our cameras interact with components via RS-485 and TTL signals. These couple API lines here, you can see we're setting the device on aux0 to an Aquaria Mark III, and the device on aux1 to a Manta Ray. Why would you script? So in an application where there are periods of time where user interaction would be inefficient or isn't possible. So common applications where there wouldn't be human interaction would be AUV, observatory, or other battery deployed scenarios where a time lapse of stills and video are required. Subsea cameras can control white LEDs, far red, and other colors of LEDs, as well as different types of lasers. The camera supplies power and strobes the LED in sync with the sensor exposure time. This reduces equipment and interface complexity. So you can see their API call for enable strobe. And SubSea has a number of plug and play options for lasers. So there are many lens options for different machine vision applications, including line, grid, and parallel points. So laser brightness of 100, would turn on your laser at 100%. Now I'll give a real-time demonstration of a camera with scripting capability. So you can see the camera running here. Along the top here, we have our heading, tilt, and roll. You can also have a depth sensor integrated, strobe control to turn on and off your strobe, and exposure control, so you can change your exposure bias. For auto exposure, you can also set it to manual exposure and adjust your ISO and your shutter speed. You can also control your focus from near to far, and everything can be full auto or full manual. Along the left, we've got some recording settings, so you can have different site names. So site 1, for example, and you can have a project name or a folder or directory name. So project 2, and we can also insert some tags, just simple tagging structures to make things a little easier. You can get down to milliseconds with tags, and you can also have custom tagging. Quality can be recorded from 4K to SD, and I'll go 4K, and we can also record H.265, which is a new codec over the last number of years. H.265 is about double the quality for the equivalent bit rate. So if you're recording at 100 megabits per second in 4K or HD, with H.265, you'll get better quality. Similar with digital stills, we have a folder naming convention. We also have file naming convention that mirrors the recording. You can change from RAW to JPEG, and you can also take digital stills continuously. So if I set it to 2 Hertz and hold down the button, you can take digital stills rapidly over a wide area and use those digital stills then for photogrammetry or other applications. You can change your white balance as well. So we can have a shallow water setting. Say if you were in shallow water and there was a lot of green, you could reduce that and adjust it for your environment to get a better image. There's similar to that theme, there's an image enhancement built in if you really can't see anything. That's for really murky environments. This is a tool so that you can at least see something to get the job done. You can also view our images and data in real time, and other computers and processing systems can access this data over Ethernet from the camera in real time. So you can record, you can have it on an observatory or an AUV or something with low bandwidth connection for video, so you don't need your live 4K back. You can record to the camera or take digital stills, download those images and video in real time, process them, and you can get very creative with your workflows to improve efficiency. NAS storage as well, so you can store to an external NAS on the network, somewhere on board the vessel. And data logging. So it's enabled right now. We can change our logging frequency, and that's in Hertz, and we can start and stop. We can also reset the IMU or set a new 0 for the IMU. That's your heading, tilt, and roll. So I'm going to reset it, and you can control your attached lamps and lasers and other devices that you have connected. On the right-hand side in the advanced settings is where we're going to be focusing. Just some quick communication connections, settings for bit rates of the live video. Here it's important to understand your time and locale settings. Time is really important for data logging. So you've got your region, your time zone. It defaults to UTC, and you can also have network time. So that would sync to an online cloud NTP server, one on board a vessel, or one even in the system, say in the case of an AUV. And you've got a local date and time, which the camera will default to if you lose your network time connection. Some diagnostic information, and this is where you set up your plug and play auxiliary devices. So you can have a number of devices here. This is what we currently support, and we can add more over time. Right now we have an Aquaria Mark III and a Manta Ray parallel laser connected. And as you add devices, the controls are accessible through the API and through the user interface here. This is the point of having this demo right now, scripting. So I'm going to run this script. And what this will do is set up a stop motion function. So it's changing it to raw format images, turning on auto exposure, autofocus. Should wait for 2 seconds now. And it's going to turn on manual focus to lock it in. Manual exposure to set the shutter speed and the ISO. And what this function will do is repeat, take a picture, wait for 2 seconds, take another picture, and then wait another 10 minutes. So that function will continue to run autonomously now. You can see a script is running through the user interface. You do not, that's something to note. You do not need to use the user interface with our cameras. We have customers that are using Python scripts and other scripts to using our API, sending commands to the camera, as using the camera as a I guess a sensor as a part of a larger system. If you would like to cancel your script, you can just turn it off this way, and that icon disappears. So now I'll write a quick demonstration script. And we can add some comments, some notes, and I'll set it to auto exposure, video name, test, and update white balance, auto, and lamp brightness 100, and start recording. And I can also have this script execute on start. So what that does is when the camera boots up, it will automatically execute that script on boot up every time the camera turns on. And there we go. So what this means for researchers and for people in the offshore and on any underwater application where you need imaging is a lot of this stuff has to be usually designed or figured out by the researcher or by the industry person, by the professional. We are working hard to try and automate things and try to make it really easy. So that's the camera demonstration. And we go back to the presentation now. So what are the benefits of scripting? It's reduced autonomous system complexity and cost. Scripting allows the camera to operate independently without requiring an additional computer or person to send commands on a schedule. For example, in an observatory, there will be a dedicated server running Python scripts or other scripts to directly control the camera node and the other sensor nodes. Normally, underwater imaging solutions would require a separate data logger. In our case, the camera is a NMEA data logger, so that reduces equipment. The camera has 512 gigabytes of solid state storage and records weeks of NMEA formatted data, days of video, and tens of thousands of images. Each additional piece of underwater equipment would require its own pressure housing and cable. So by reducing components such as data loggers and controlling systems, you reduce the cost and you increase the reliability. And when a system also has less components, you would also expect it to consume less power from battery systems. So I'm just going to show you a few real world examples. So SubSea has been working with the OOI, Ocean Observatories Initiative in Washington State for a long time now. So this is a video. This is a video at the axial seamount. It's several hundred kilometers off of Washington State. They've been using our cameras for a long-term time lapse of images and video of a hydrothermal vent. The OOI is a very large networked infrastructure of hundreds of different sensors at different sensor nodes. They're all connected with a large fiber optic network back to a giant server station at the University of Washington's Applied Physics Laboratory. This particular hydrothermal event has been studied since 2014 with subsea cameras. It's called the mushroom, and the hot spring fluids can reach temperatures, very high temperatures. The creatures that reside there, living on this structure, shift and change over time. Different populations go up and down as time goes forward, and the vent structure itself changes shape as well. So it's a very interesting study over a very long duration. So if you'd like to know more about that, you can see more on our site or on the OOI site. One second. Okay. There we go. Okay, trying to figure out how to use these slides. All right, so this option was developed with the Ocean Observatory Initiative on the West Coast of the United States. It turns the camera into an Ethernet multiplexer for 4 devices with a resettable circuit breaker and fault detection. So this is another piece of automation. Essentially, it reduced the need for having a separate Ethernet switch with relays and fault detection, and we moved everything into the camera so that the camera was the hub, and we could automatically detect faults from under voltage, over voltage, or short circuit from other equipment. So we had a pan tilt, 2 LEDs, and a set of parallel lasers all running from the camera, and the camera was the hub for that. And everything was accessible through the API for scripting. The Marine Institute in Newfoundland has been using subsea cameras with scripting and intervalometer for many scientific studies. Their system runs on batteries and attached to a lift wire. The systems are deployed between 100 meters to 3,000 meters on these lift wires, and it's all autonomous. So the cameras are programmed before deployment on the deck of the ships. The operator doesn't have a real-time view of the footage, and it goes along and it hits rocks and does other things, but it's quite robust because it's a heavy steel frame running on batteries. The system is used in fishery studies to add data for stock assessments. In this set of clips, the Marine Institute was conducting a turbot fish study. So the same deployment methods have also been used to study Greenland sharks and other species. Here you can see SubSea's new towed camera solution being tested in the world's largest flume tank at the Marine Institute in Newfoundland. You can see a digital still script running as the LED strobes in sync with the ray fin camera. You'll notice the green dots on the bottom of the tank as the manta ray parallel lasers are activated. The dots are calibrated at 10 centimeter spacing and can be used for scale and range. With this system, a live view is available, so scripting is not 100% necessary, but it's definitely useful for automation. So an example of this would be if you wanted the system to automatically start recording at a certain depth, you could do that, and that takes some of the guesswork out of it. University of Victoria has been using SubSea's observatory solution for their underwater study in Barkley Canyon since 2014. And in May 2014, 3 humpback whale rib sections, 1 block of Douglas fir, and a block of orthogenetic carbonate were placed at a depth of 890 meters inside Barkley Canyon at a site on Ocean Networks Canada's Neptune Subsea Camera Observatory. The purpose of this experiment is to monitor the changes triggered by the implantation of various organic and inorganic substrates, as well as to monitor how benthic creatures utilize the sparse food resources available in deep sea settings. So on a schedule of every 2 hours, the autonomous subsea cameras and the LEDs, they pan to 3 different substrates while holding position for 1 minute each, and they captured 5-minute videos over 6 years. And the study is still continuing today. So it's a small kind of hotbed of activity for creatures because the abyssal plain is pretty sparse. So these site is kind of attracts species from a wide area. In the webinar theme of remote operation and the new normal, we thought it would be relevant to give a quick overview of the new Subsea real-time streaming service as well. It enables remote operation of assets, so kind of counter to our previous friend. We are enabling that. Our hands are off from there. We're enabling the service. We don't decide whether you want to use it. So this service enables remote operation of assets and allows decision makers to access live video from anywhere in the world. So here's how it works. The streaming solution sends offshore video sources to a cloud server. From the cloud server, your video feeds are sent to your secure Subsea streaming account. From anywhere in the world, your account manager can log in to set up live video presentations. And you can then send your presentation secure access code via email. So, because security is paramount, you can send that secure access code to your clients and your coworkers who need to be in on it. Offshore real-time streaming allows everyone inside your operation to connect through a low latency, high quality video feed with audio and data feeds coming soon. So each presentation can have 4 low latency video sources and multiple viewers at the same time. Our streaming solution offers secure HD offshore streaming with flexible bandwidth, frame rate and quality, and a measured latency of actually less than 1 second. It's also a cloud-based software that can be downloaded onto any PC, and it's compatible with all camera standards. So there's no additional hardware required, and all you need is an internet connection on a Windows PC. We're offering a free 30 days right now, so it's very easy to start it. And if you're interested, you can email team@SubC. We are here to help with your remote operations. So in conclusion, most Subsea projects require many components. Integration of these components can lead to high costs and complexity. Scripting reduces those complexities and costs, and it can save time while also increasing reliability. Subsea has a number of well-designed solutions that can be easily adapted to your requirements. And if you're interested in learning more about Subsea and our solutions, our qualified team is here to help with your application. Check out our website, subseaimaging.com for more, and thank you.